Hey guys, welcome to the Algebra Prep Questions Part 4. Let's go ahead and get started with this problem right here. It says in ideal conditions, 200 colony forming units of E. coli can grow to 400 in 20 minutes and 800 in 40 minutes and then 1600 in an hour. So it says Part A, says that Jenny says that the E. coli growth can be modeled with an exponential function. Do you agree? Justify your answer. So if it is an exponential function, that means that we're going to be going up by a constant ratio. So if it is, we will be going up by a constant ratio. So let's see if it is going up by a constant ratio. What do we got? We've got 200, and then we've got 400, and then we've got 800, and then we've got 1600. So how do I go from 200 to 400? Well, if you don't see how you want to either think multiplying or dividing. If you can't see that, you can always do 400 divided by 200. What's 400 divided by 200? Well, that is 2. So we know that we're going up by a rate of times 2. What about here? Well, 400 to 800 I know is also times 2. And then 800 to 1600 I know is also times 2. So it is going up by a constant ratio, therefore it is an exponential function. So because we are going up at a rate of times 2, this is an exponential. This is an exponential function. So yes. Oh no, it is an exponential function. So part B, just a heads up, I don't like this question. It says write the equation that models the function. So when I did this, first of all, for an exponential function, we have y equals a r, typically written like this, where a is your initial amount, and r is your constant ratio. So they're talking about in the problem, they're talking about every 20 minutes, right? So if you wanted to write a function right like this, per every 20 minutes, you could do, okay, what's your initial amount? Well, your initial amount, you started with 200, so I'll say 200. And what are we going up by every time? What's our constant ratio? Well, we just said in the last one that was times 2. So I'll just put a 2 here, and then I'll put x. So this works for me. This is for every 20 minutes. So for every 20 minutes, you can use this function to model this problem. The answer key, for whatever reason, had y equals 208 to the x, and this would be per hour, okay? So if you had either one of these, I'm okay with that. So either one is okay. So either one of those is okay. I think the question should have been a little more specific, but that's just me. All right, and then part C, graph the situation. Honestly, in a question like this for a state test, as long as you know that it is going to look something like, like a curve that goes up, then that should be good enough. But let's go ahead and see if we can't model it. I'm gonna do, let's say we start at 0, 1, 2, 3, 4, 5, 6, 7. And let's say that each one of these each unit is 20 minutes. So each one of those is 20 minutes. So that's 20 minutes, 20 minutes, 20 minutes, 20 minutes, 20 minutes. I guess I could have done 0, 20, 40, 80, but that's okay. And then we'll go, this will be 200, 400, 600, 800, 1,000, 1,200, 1,400, and 1,600. All right, so where are we at? You know what? Let me just go ahead and change that. I'll do 20s. That'll be easier. So let's do 20, 40, 60, 80, 100, 120. It should be good enough. So at 0, where are we at? Well, we're at 20 or 200. Excuse me. At 20 minutes, we are at 400. At 40 minutes, we're at 800. 60 minutes, we're at 1,600. So we kind of get something that looks like this. So, you know, your graphs will vary depending on your axes. So, but just in general, it's right over here. In general, exponential functions look like this. So they look something like that. All right. Stay tuned for the next video, and I'll see you guys soon.